Good afternoon, and great to be here. Glad to hear all the excitement over small sats, and we're very involved with them at Interorbital Systems, so much so that we're developing a dedicated small sat launcher. There it is, the 5-module N5 or Neptune 5. At Interorbital, we build everything. We do not outsource our rocket components. Everything is completed in-house, and we've been based at the Mojave Air and Spaceport since 1996, where we have R&D facilities and 2 rocket test sites. We build absolutely everything. That includes the engines, the tankage, guidance systems, our own software, basically everything. And those are all integrated into the main building block for our modular satellite launch system. Again, the Neptune, and the first iteration of that will be the Neptune 5, which will be 5 of these common propulsion modules. You see it there on its mobile gantry. It's basically a standalone sounding rocket, and we'll be offering rides on that soon, 145 kilos to 310 kilometer altitude is the performance for this particular vehicle. There it is on its mobile lift. And what we do is integrate our engines and thrusters into those units. We've had decades of experience in building propulsion systems. Our key propellant combination is turpentine and white fuming nitric acid, very high density, and a very good and inexpensive substitute for the more expensive and toxic hypervols of hydrazine and nitrogen tetroxide. Get similar performance with our green propellants, as we like to call them. We just did this test of the engine, a pre-flight qualification of our 7,500 pound thrust nitric acid turpentine engine. These engines will be integrated into 5 CPMs, and again, that'll be our orbital launch vehicle. Prior to that, we'll have a suborbital flight. Looks like about the 2nd week of December, with 1 CPM and that engine. That's about a 24-foot flame you see there. And that incandescent look is characteristic of the hydrocarbon burn with nitric acid. This is a configuration of the N5. It's a 3-stage orbital vehicle. And it fits the nano launcher characteristics of being able to be fit into a 40-foot container. Very, very mobile and quite inexpensive to make. As part of our low-cost regime, we have kind of nixed any federal spaceport use because of the cost and the scheduling problems, and have gone strictly for ocean launch unless the customer wants land launch. That gives us complete flexibility. The customer could also not only choose a schedule, but can choose the inclination. We can go wherever there's an ocean and get that designated as our spaceport. And our spaceport consists of a launch canister and a ballast unit. So it's as minimal as you can get, as cheap as you can get, and it provides launch on demand. Our first 2 orbital launches will take place off the coast of California, probably somewhere around 150 miles off, and those will start in 2014. We have currently 64 payloads, so the first 2 launches are sold out, and we're booking the 3rd. For our interplanetary launches and our lunar launches, We're looking at using the Big Island of Hawaii as a staging area for ocean-based launch. We had looked at Tonga in the past, but there are ITAR issues from our government. And so until we get those sorted out, we'll be using very much like to use, actually, Hawaii for those Google Lunar X Prize launches. And again, I forgot to say that we are actually in the Google Lunar X Prize with Team Synergy Moon. I think we're one of the only ones developing our own launch vehicle. But again, it's a perfect spot for lunar and interplanetary mission launches. Our moon missions will be carried out with an N1000, that's 1,000 kilograms to LEO, or about 40 kilograms to the lunar surface. And this is based on our N5 technology, not necessarily the same type of vehicle, but all the things we've learned gearing up through the orbital vehicles will be applied to the moon rocket. Our first moon mission will be the Synergy Moon flight in 2015. We already have customers for a second mission. That's a lunar sample return mission. And 2 customers, as I mentioned, are lined up for that. That's something we've been planning for quite a while. Actually, since 1996, when we founded both Interorbital Systems and Translunar Research, which is a nonprofit dedicated to lunar colonization and exploitation. We have upcoming missions. I should mention also that we did receive a NASA SBIR in 2012 towards the development of our nano launcher. And with these variants of the vehicle, we have quite a few flights coming up. Specifically, that sounding rocket flight that is still open for purchase. We're looking at about $350,000 for that flight. And again, it's 145 kilos to 310 kilometers. Looking at spring for that. Doing a high altitude rocket dive with Olaf Zipser. That's coming up for use on a modified SR-145. And the small sat flights will start 2014, Google Lunar X Prize 2015, that private sector lunar sample also 2015 to 16, and we're looking at doing manned flights and orbital expedition space tourism, probably more near 2016. We fund ourselves totally. Most of our revenue comes from our satellite kit and launch program, and if you're looking for the ultimate Christmas present, for $8,000, you can buy a TubeSat kit and launch, and nobody will ever call you a piker anymore, right? Not after that. So this is widely accepted around the world and has become the center of a number of curricula. Really popular in Brazil and in I think 16 countries now, in addition to the US. Arts, science, and military projects are on board with all those payloads. Another shot of the SR-145, and again, that's coming up. If you need a high altitude launch to space altitude, let me know. And a couple of pictures of our team in action there in Mojave, testing equipment and getting ready for our sounding rocket launch in December. So thank you.